This is an introduction to using the CPU monitor. The first thing I'm going to do is just set a bit of context. So I'm going to go across to the Altair 8800 Wikipedia article, and we're just going to scroll down through here. And we're going to look at the front panel. You'll notice there are quite a lot of switches on the front panel, and this is how you program the Altair before you had a terminal. You'd flick these switches and load in data. So starting on the left, we've got the stop and run key, which you could stop and run the CPU. You could single step through the CPU, so you could single step through each instruction. You could go and set, examine. What that would do is you could go and set the current CPU instruction pointer at a particular address. Examine next would basically step through to that next address. Deposit, you could go and deposit an instruction or data at a particular address, and deposit next, we go and put it at the next location. Okay, so in the middle of the panel, you would see a series of switches. So we've got switch 0 all the way to switch 15, and that would represents the 16 bits of the address bus, and you'd also use it to go and set the 8 bits for the address bus. The LEDs here in the middle, the first, the row here from A15 to A0 would show the current value of the address pointer and the bus, and at the top setup here would be the data bus and the current value in that. Okay, so we're going to go back to the Altair Emulator. So just remember those switches, and what we're going to do is we're going to go across to the V drive. And I'm going to type in, look at an application called demo.asm. Okay, so this is a very simple demo, and surprise, surprise, it's going to write out hello world. And what we're going to do now is I'm just going to run demo. In fact, just so you know, the way you assemble it, you go assemble demo, and you go load demo, and then we go and run demo. And actually, yeah, that'll be enough. And if we look up here, we can see that what happens is that this bit of code gets loaded by the CPM operating system to address hex 100. And you can see that there are basically 4 instructions. There's a move immediate, the C register, and it's going to put the value 09 hex in there. And then we've got, I think it's load immediate or something along those lines, into register D, and then we're going to call a particular location. What this is doing is going to call BDOS, and BDOS was a location in the operating system for printing out strings, and the string we're going to print out is hello world. So I've just run demo, so that means that that application is currently sitting in memory still. And what I'm going to do is going to switch into the CPU mode and press Control C by doing that. And just so you know, there's a bit of a reference to it up there in the top right hand corner as well. And what I'm going to do is I'm going to enter in fact, this is a little trick. In fact, we made a mistake. The web terminal is still in wordmaster mode, which is character by character mode. To use a CPU monitor, you must switch into line input mode. So I press Control L, and you'll see it's now back in default. So what I'm going to do is I'm going to enter hex 100, which is 1 with 8 zeros. Press the enter key on that. And you'll now see that we've got hex 100 I've loaded. So that's equivalent of flicking those 16 switches in the middle to go and set an address bus. And what I'm going to do is I'm now going to equivalent of flick the examine, which is going to set the CPU. So I'm going to type in E. And what that's done is it's set the CPU address pointer, next instruction pointer to hex 100. And you'll see that in there we've got this instruction called move C. And if we come and look up in our assembler code, we'll see, amazingly enough, we've got move C. And you remember it's got hex 9 in there. And we come down here and we're going to do an examine next. And you'll see that we've now got, at that next address location, we've got 09 hex. And just a bit of information here. So we've got this move immediate instruction, and you'll see it tells you that it's a 2-byte instruction. So it means that the next byte is going to be data, which is related to that instruction. If we can hover across over here, you can see we've got the address. You can see that in hex, and we also put that in octal. It's quite useful to have this stuff in octal as well. And you'll see the data bus is, that's from the data bus, that's the opcode for move immediate. And you can actually see that is the hex value, and that's the octal value there. So that's kind of how to interpret that. And what I can do now, if I go and press Control M, what that's going to do is it's going to start the CPU running. In fact, what I'm going to do, just to make sure this works properly, we'll just go and reset the CPU instruction pointer to hex 100. And then what I'm going to do is I'm going to go Control M. And what that's going to do, it's going to start up the CPU at hex 100. And surprisingly enough, it will go and write hello world, because that was what was still loaded in at hex 100. Now you'll also notice that it doesn't come back to the A prompt, and you might be thinking, why is that? And the reason being is that when CPM loads up demo.com into memory, what it does on the stack, it pushes the return address back into the operating system. But the way I've done it directly from the CPU monitor, I loaded up hex 100 and then I hit run again. When you do the return, it didn't know where to return. And probably it returned into some random location in memory, and effectively the operating system has died. So what you need to go and do is press Control M again, and then just go and do R for reset. And what that will do is clear out the memory and reset CPM and reload CPM. So that's kind of how you can work with that. Now I'm going to show a couple of other things, tricks you can do with the CPU monitor. We go back, Control M. If you watched another video, you might have already seen me do this. But if I type in Basic, that will load in Altair Basic. And I have the opportunity, this is the original Altair Basic that was written by Bill Gates and Paul Allen, and runs really against the metal on the Altair. And we're going to say the terminal width is 80, which I think is a default, and I'm going to say yes to loading up those functions. And there I've got, and we'll just go and type hello world. I know it should have a comma in there, but we'll run this, and we've got hello world. Now, so that's how you can drop into the Altair Basic. But most of the time, 99% of the time, you really got to want to spend your time inside CPM, because you've got full access to a file system. You can save applications and things like that. And to reload CPM, you go and hit R for reset or reboot. Okay, so we're just going to run demo again and go to the right drive. We'll run demo again. And I'm going to go back to the CPU monitor. We'll go and load up hex 100. That feels like too many zeros. And we've got hex 100, and we're going to do an examine. What you can do is you can do an L for list. And what that would do is it'll list out, I think it was the 20 or 30 instructions, and it's basically step through the memory address space. At hex 100, we know there's move immediate, and then we know that it's a 2-byte instruction. So that next value there will be related to that instruction. Then the next instruction here was this load immediate, I think probably from the address, so it wants a 16-bit, so it says up here that it's a 3-byte instruction. So with the next 2 bytes there, we know a low order and high order bits for the address bus. And then what this is going to do, this is going to call the BDOS function for displaying a string onto the console. And you can see it's loading up the address location for that system level function to go and display something. Okay, so that's how you can go and do list code. Now the other thing you can do is you can do what's called a trace. Now a trace, so the list would just go through memory and just load out and display what's in that memory address space. Now what a trace does, a trace actually goes and executes that code. So of course it's going to jump around depending on what's the logic of that code that's loaded in memory. So I can go and put T for trace. And what you'll see here is we just scroll back up a bit where I put T in. So we had the move immediate, and you'll see when we go to do the call, you'll now see we're going into system level code. I can do trace again, and then we just step through the code as it executes. And if I come out of the CPU monitor, Control M, you'll see hello world. So that kind of executed that system level code. I completed that. To run and display hello world on the console. And again, same reason before, hello world doesn't know where to exit back to, so you need to go and reboot the operating system. Now I'm going to show one last trick, and this is much more discussed in the documentation. Now there is a command in here called DDT, and you'll find this in the CPM documents. And if I go DDT, And I can't remember 100% how to use this, but we've got enough to get going. And what this does, it's a little bit like CPU Monitor, but it's running really in the context of CPM, whereas a CPM Monitor is running kind of underneath the operating system. If that makes sense, it's kind of running below the Intel 8080 emulator, whereas DDT is really running in the context of the CPM operating system. And that has commands on there like trace, and you can step through your code and things like that. I think there's also a list as well, so you can go and look at the code. Again, you look through the documentation, you can go and set the current instruction pointer and stuff like that. But we'll just jump out of that, we'll reboot, and we're back to a clear way. So CPU, the CPU monitor, super useful if you're writing any assembler code, or if you just want to understand how a CPU works, how it gets laid out into memory, stepping through your code, and just kind of learning stuff there around how operating systems work, how our applications work, and how applications get loaded and executed. As I said, Control M is your friend to get in there and play around in what you can do in the CPU monitor. Anyway, have fun and enjoy.